on PW Gate Wala channel, and today in this specific session we are going to solve a lot of previous year questions which were asked in GATE, and of course it will be very crucial for us to practice these questions now, just because we will have certainly a lot of benefits out of these. Similar kind of questions are being asked many a times in GATE examination, and if we will practice them, we will definitely get a few questions in this year also. Now that is the expectation we can have. So let's get started. But before that, I can tell you, yesterday we had a really great, energetic, successful, complete Maha revision, which was complete revision of entire course of COA on the channel Gate Wala, which is ECECS. Now then now here on this specific channel we are having the PYQ discussion. Of course I'll be discussing in English, complete discussion. Next is we are going to have another practice session. Yes, my friends, we do have another practice session at 7 p.m. and that will be purely only practice, but not PYQ and not anything else. 7 p.m. we have another practice session on the same channel where we had the discussion of Maha revision. Okay, so let's buckle up, have your pen and paper, and let's get started. We will be just discussing the questions today. If you see a question which you have already solved and you remember the answer, please do not answer until the people who will try to answer by solving the question. Okay, fine. So I want the message. Are you guys ready for the practice? Yes or no? And we will start. Okay, I can see a lot of people over here already joined. Shubham, Pavan, Jitesh, Abhinay, then Raj. Okay, Cypher, OP, K, Ashish, Yugandhar, and Rohit, Ashik. Okay, great, ready. Okay, then there is very first question, very easy to start with. See, I have brought questions which are, I think, very commonly asked nowadays. So we can touch them and we can recall how to solve the questions. Okay, here is the very first question of the day. Let's go. I think we should have a timer. We should have a timer. Yes, right. This particular timer will be in the corner and I'll give you 90 seconds to solve this question. 90 seconds. Just 90 seconds. Thirty seconds gone. 1 more minute to go. Ready? Okay, great. Venkat, Roshan, Vikas, Gokulam, Aniket Kumar, Arpit, Sayan, Jitesh, Raj, Yugandhar. So many members. 45 more seconds to go. Last 30 seconds. People are getting answers. B and D. I can't understand. It is ulta B or seedha B. Complete. More 15 seconds more. I'll give you 15 more seconds. It is very easy to start with. The question is very simple. I have brought so many questions. We will be solving a lot of questions. We will be touching these questions so that we can have the discussion around the most important topics. Time is over, man. Time is over. What is the answer? So many members are having different answer. B, D, 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 B, D, D, B, D, D, B, D, D. Okay, look at this. What it says. A processor says uses fully associative cache. In fully associative cache, we divide the main memory address only in two parts. The two parts are tag and byte offset. That's it. Next, 16 kilobyte size. The cache block size is 16 byte. If block size is 16 byte, 2 power 4 byte, then offset, byte offset will be of what? 4 bits. Wow, 4 bits byte offset. The main memory is byte addressable and uses 32 bits address. Complete main memory address 32 bits. Among that, 4 gone. 28 bits remaining for tag. How many bits are required for tag and index? In this, is there any middle field, set, offset or block number or something? No. Index field 0. Yesterday also we talked about it. 0 bits. So tag 28, index 0. Answer is D. Correct option is D. 28 bit for tag, 0 bits for index. In the fully associative mapping, minimum index bits are there, which is 0. Maximum index bits are there in the direct mapping. This is the theoretical question. MSQ में पूछा जा सकता है. It can be asked in MSQ. And minimum tag bits in direct mapping, maximum tag bits in fully associative. Too much tag. 28 bit tag, that is too much. Okay, next question. Here it is. Fresh. Last year's question. Very fresh. Another 1.5 minute timer for you guys. Sir, when we will have new variety of question? Evening 7 p.m. 7 p.m. we have not the PYQ type of questions. Last, 2023. Now it becomes last to last year. 2 year gone. One and a half minute total. Answer is very simple to get. I am getting 2 different answers. Oh, 3 different answers. 19, 21. Arre wow. What a pattern I am getting, huh? Like this. Something feeling like I am printing through C program. There are a lot of such kind of patterns we used to print when we used to learn C programming. 1.5 minute gone. You want more time? You want more time? Let me know you want more time. In GATE examination for such kind of question, you will have to solve such questions quickly, boss, quickly. Okay, let us solve this question. Stop. 8-way set associative cache of size 64 kilobyte, 1 kilobyte is 1024 bytes, is used in system with 32-bit addresses. Main memory addresses 32 bits. Great. Associative mapping, we divide main memory address into 3 parts. Tag and what is that? Set offset and byte offset. Good enough. Next, the address is subdivided into tag, index and block. Of course, block offset means byte number. Index is nothing but set number. The number of bits in tag. See, block size is not given. This is their prime type of question. Most of the time they ask this question. So many times. In last 6 years, they have asked 4 times this question only. And we have yesterday only discussed these 2 parts. Log of cache size minus log of associativity. Cache size 64 kilobyte, which is 64 2 power 6, kilo 2 की power 10, 2 power 16 byte. So log of 2 power 16 minus log of associativity 8. 16, 2 power 16 log is 16 minus log of 2 power 3, which is 3. 16 minus 3 is 13. Among 32, 13 gone. Tag remaining is 19. 32 minus 13, 19 bit tag. That is the answer. And you know, what am I saying? What am I saying? This type of question, if you practice 3-4 non-stop, You will be able to solve such question without writing anything. In the mind itself, everything solved. 32-bit complete. Okay, 16 minus 3, 13. 32 minus 13, 19 bits. Directly. Okay, next. Another question. 2016, similar kind of question. Now I'll give you just 1 minute to get the answer done. Reading the question and solving the question, both done in just 1 minute. This is so easy this time. One. See, 30 seconds gone already. Last few more seconds. Okay, time over. Width of physical address on a machine 40 bits. Physical address means main memory address 40 bit. The width of tag field in 510 kilobyte 8-way set associative cache is how much bits? So cache size 512, 8-way set associative. So we divide main memory address in set associative cache in three parts: tag, set, and byte offset. These two parts will be log of cache size, log of 512k minus log of associativity 8. 512k 19, so log of 2 power 19 is 19 minus 2 power 3, which is 3. 19 minus 3, 16. 40 minus 16 is 24 bit. Answer is 24 bit. You get just in few seconds 1 mark awarded, and you will have just a happy face if such kind of question comes and you can solve easily. I have told these points again and again and again. I am saying, my dear friends, if you want to score more and more in GATE examination, you will have to solve the same type of question, known type of question, commonly asked questions in minimum possible time, so that you can spend little extra time on some kind of new questions which you can easily solve if you spend little extra time, just because you don't know the approach immediately. You will have to save the time for them, and that's why known type of question you'll have to solve as quick as possible. Another question, GATE 2018, one of the toughest paper it was. Ravi, that is not being set in my system. That's why we are having this timer. Okay, I'll give you approximately 2 minutes for this question. Minutes, 1 minute gone. Okay, 2.5 minutes I can give you. Think of this. Few more seconds. Getting the answer. B B B B B B B B B B B D D D B D A. Okay. Different answers. Hmm. Okay, 2.5 minutes gone. I have given enough time to you guys. Let's see. Size of physical address space. Address space means main memory size. Processor is 2 power p bytes. If 2 power p bytes is the physical address space, can I get the main memory address size? Main memory address can be of p bits. Log of 2 power p. The word length is 2 power w bytes, capacity of cache memory is 2 power n bytes, size of cache block is 2 power m words, the k way set associative cache memory, the length of tag field is whatever we have solved. Two questions. Exactly same concept I am going to use. I don't care what is the block size, byte offset how many bits, set offset how many bits. I don't care. Why? Just because I don't need it. Why? Directly I'll use this concept and I'll get the answer of the tag. Even though you get the size of the block offset and set offset also, you will get exactly same answer which I'm gonna get here. So look at this. In the set associative mapping, main memory address divided into three parts: tag, set which is index, and byte offset. Now what happens? These two parts are log of cache size. Cache size 2 power n minus log of associativity k. Complete main memory address p bits. So what is the tag then? Tag remains among p from a complete address p. Subtract this. Log of 2 power n is n minus log k base 2. So I'll subtract this from p n minus log k base 2 and I'll come up with p minus n minus minus plus log of k base 2. Which option is correct? B option. Now see, there are so many members. Even though this examination GATE 2018, this one, I got 440 rank. This answer, of course, I made correctly. But you know what I was doing? When I was solving this question, I knew this concept. Directly, I was trying to solve without writing anything. So in my mind, I thought n minus log k, I'll have to subtract from p. So in my mind, p minus log n or p minus n minus log k. What has happened? I was subtracting this from the p and I was getting such kind of answer. I at first place made this answer corrected. Tick marked. Then I thought, let me just write down once for the confirmation. So I have written down. When I understood, oh, I'll have to subtract this complete subtraction, and because of that minus minus becomes plus, and I had to go with option B, which is actually the correct answer. आप इस बार गेट लिखेंगे? नो बेटा, नो, I will not write. Base 2 is not given, then consider 10. Of course, base 2 should be given, will be given, for sure will be given. Now, if anybody having, sir, word length क्यों है? See, word length, block size, whatever is given is to confuse you or to make you engaged into calculating byte offset and set offset. People who don't know this kind of concept, people who are not studying in the depth, they will go with what? First byte offset, then set offset, then tag. Like this they will calculate, and because of that they'll spend a lot of time. You want me to do that? Should I calculate byte offset and set offset for you guys? Still you will have the same answer, option B. I don't mind solving it if you want to, but it will take another 2 to 5 minutes and that will not be needed for us. See this, why such kind of questions they are saying, They have given block size in words, but block size I'll have to calculate in bytes. Why? Just because I do have byte offset. Why? Main memory is always byte addressable. Otherwise, if until otherwise is not given, the opposite is not given. If main memory word addressable not given, by default it is byte addressable. If main memory is byte addressable, then I'll have to take block size in bytes and everything in byte offset. But if main memory is word addressable, I'll have to calculate main memory address for each word, and here also block size I'll have to take in words and word offset I'll use. That is very rare nowadays, questions are not asked, but still we need to know this. Should I go ahead with this? Should I calculate how many bits are there in set offset and byte offset? Do you want me to do that? I'll go with majority. Whatever you say, I'll do. No. Okay, then let's go next. Question. One person saying yes, remaining are saying no. Another question. 2014. Another question is asked. Similar kind of. Here is the timer. Let's go. चलो 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 चलो, ज्यादा टाइम बचा नहीं है. We do have 50 seconds gone. We got two answers, three answers, four answers. Oh, when we get two answers same to same, then we will get lot of answers same to same. All copy paste. You solve your own question, Ra. You solve your own questions. Get the answer by yourself. Try. No copy paste. Okay, 1.5 minutes gone. Answer. One answer is different. 21 remaining 20. How is it possible? Let's see. Wait. 4-way set associative cache memory unit with a capacity of 16 kilobyte is built using a block size of 8 words. The word length 32 bits. Size of physical address space 4 GB. The number of bits for tag is what? I don't care about the block size and word size. I will just directly calculate. 4 GB is physical address. 4G 2 power 32 byte. Hence, can I get main memory address 32 bits here? Can I get main memory address 32 bits here? Yes or no? In the set associative mapping, 32-bit main memory address we divide into three parts: tag, set, and byte. Next, these three parts, we know these two parts are log of cache size, 16 kilobyte, 16 2 power 4, kilo 2 power 10, 14. Log of 2 power 14 minus log of associativity. What is associativity? 4-way. 14 minus 2, 12 bits. 32 minus 12, tag remaining 20 bits. Answer is 20 bits. That's it. Done. Answer is 20. I don't care about what is the word size and block size, etc. Why? Just because I don't need it to get the tag. If they ask what is the set offset, I'll have to use it. If they ask what is the byte offset, I'll have to use it. If they are asking just tag, I know these two fields together is this. I'll just subtract that from the main memory address directly. Such kind of question we have solved already. Look at this. Another question. Since here till now everything was given, tag was asked, this time everything is given and associativity is asked. Let's go. If you can solve it. 2 more minutes I'll give you for this question. Let's go if you can solve it. 2 minutes. I'll give you 2 minutes for solving this question. You may take little time for this one. I'm getting answer 2, 4, 2, 3. Array 3 is not possible for sure. Associativity cannot be 3-way set associative for sure. 3-way set associative, there isn't any possibility. Either 2-way or 4-way or 8-way or something like this you will be getting, but not for sure that associativity cannot be 3-way associative. Yeah. Okay, 2 minutes gone, 2 minutes gone, 2 minutes gone. Sir, Rashmi, go for practice and revision, leave everything now. Set associative cache of 2 kilobyte. 2 kilobyte. 2k is 2 power 11. 1k 2 ki power 10. 2k is 2 power 11. With cache block size 64 byte, assume that cache is byte addressable and 32 bits address is used for accessing the cache. If width of tag field is 22 bits, tag is given, associativity is asked. Again, same thing I'll be doing. I will not waste my time in byte offset, set offset, etc. Directly I'll give tag, set, byte. These three fields I'll divide the main memory address, which is of 32 bits. Among 32 bits, tag is 22 bits. Given in the question, directly, tag 22 among 32. So remaining these two fields should be 10 bits. And we know that these 10 bits are equal to log of cache size. Cache size 2 power 11 minus log of associativity. 10 is equal to 2 power 11 is 11 minus log k. Log k is equal to 10, 11 minus 10 is 1. What should be k so that I can get associativity or log of something is 1? Answer is 2. Log of 2 base 2 is 1. So answer is 2. Two-way set associative. Answer is 2. Okay, so similar kind of look at the same concept. How many questions? Even though I have not brought all the questions. I have not brought all the questions which are even asked in the GATE examination. Same concept again and again and again. We solved enough. Let's go with the another concept now. Tag directory size. Metadata or tag directory size. Okay, 2 minutes to solve this question for you guys. You guys are really good. Solve, 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 solve. Solve the question. Question is about direct mapping, okay? Two people are saying option A, I did this in the morning only, get the answer and give me the answer here. I will give you 2.5 minutes to solve this question. 45 more minutes, or sorry, seconds to go. Last few seconds. Okay, I'll extend it to 3 minutes. If you guys are solving, try and get the correct answer. That's important here. You need to understand the concept, man. You understand the concept, get the correct answer. And a few more seconds, few more seconds, few more seconds. Okay, stop. 8 kilobyte direct mapped write back cache is organized as multiple blocks. Of course, cache has lots of blocks. We know each of the size 32 bytes, block size 32 bytes. The processor generates 32-bit addresses. The cache controller maintains tag information for each cache block comprising of the following. So tag information for each block comprising what? One valid bit, one modified bit, as many bits as minimum needed to identify the memory block mapped in cache. So for each block, we are maintaining three types of things: one valid bit, one modified bit, and some bits to identify memory block in the cache. We learnt it very well that which main memory block is currently present in cache, that is identified with the help of tag. So they are saying that for each block we are maintaining tag and one valid bit, one modified bit. Modified bit is dirty bit. What is the total size of memory needed at cache controller to maintain the metadata tags for the cache? The formula of metadata is very simple. Number of blocks in cache multiply by tag plus extra bits. And this formula works for all the type of mapping. Same to same formula, just because whether it is two-way or four-way or fully associative cache or direct mapped cache, for each block we will have to maintain tag and other bits. For each block we will have to maintain these bits. Each block, okay? So for each block these many bits. Fine, now number of blocks and tag I'll have to calculate. So direct mapping will have to divide the main memory address into three parts: tag and block and byte. What is the main memory address? कहाँ दे रखा है भाई? Main memory address. This CPU generates always main memory address 32 bits. Among 32 bits, block. What is the block size? Based on that, we will calculate byte offset 32 bits. Sorry, 32 bytes. 32 is 2 power what? 5. So byte offset is 5. Blocks size 2 power 5 bytes, hence offset is 2 power 5. Either you can go directly with this or you can calculate number of blocks separately. Whatever you do. I do prefer this just because it becomes easier for me. I'll do both for you guys. This is log of cache size. Block and byte together, log of cache size. Cache size 8K. 8 is 2 power 3, K 2 power 10, 2 power 13. So log of 2 power 13 means 13 bits. If this is complete 13 bits, among that byte offset 5, remaining 8 bits will go for block. If you will calculate number of blocks in cache, you will get 2 power 8. Hence 8 bits for block number. You want to? I'll calculate that also. Number of blocks in cache. Cache size divided by block size. 8K 2 power 13 divided by 32 2 power 5. Answer is 2 power 8. See, 8 bits. Total 13 gone here. 32 minus 13, 19 remaining for tag. Now let's put up all all the values here. Number of blocks in cache 2 power 8. For each block we are maintaining 19-bit tag plus 2 bits extra, one valid bit, one modified bit, which is given in the question. Given in the question, then so 19 plus 2, 21 into 256, 5376 bits will be the answer. D is the correct one. What if write through is given? One dirty bit is given with add dirty bit to Ashik Saini. These type of questions are created by IIT professors, and those people are not people like us, like me, who are creating the test series. Test series people are giving such kind of nonsense question. Sometimes I also can, think of that way, but they will not. In the write through cache, there is no any need of dirty bit. Hence, we will not have this dirty bit or modified bit given in the question if it will be a write through cache. In write through cache, if it is direct mapped, we will utilize only one thing, or we will use only one extra bit, that is the that valid bit. That's it. Okay? Good enough? Anna? See, the thing is, what happens? Modified bit is not used in the write through cache. So they'll not give it at all. They'll not mention it at all. है ना? Chal. Okay, next question. Here it is. Another type of similar question. Let's go. Directly, indirectly, if we know formula and some basics, we can solve easily. Yes, of course. That is what the thing. If you remember the basic things, you can easily get the marks. But that basic things you will have to distribute over 12 subjects. All 12 subjects, basic things, if you remember, you can score well, more marks from each subject. A few marks you can score easily. 2.5 minutes. A, C. There is a tussle between A and C. Okay. Let us see what is the correct answer. 3 minutes. 3 minutes. I'll give you 3 minutes to solve the question. Go easy, man. Go easy. A, C. If you will answer 4 times A also, you will get same 2 marks only for each question, Ra. Even if you write only once also A, I understand you got the answer A or C, whatever it is. You did not listen me properly. You did not listen me properly. I have just now, few minutes ago, told you The formula of calculating tag directory size is same. This number of blocks in cache into tag plus extra bits for all the type of mapping. Does not matter if it is direct mapping or fully associative mapping or set associative mapping. Formula is same. Why? Just because even if we maintain four-way set associative cache, in the single set we can maintain 4 blocks. But these 4 blocks are 4 different blocks. 4 different blocks of main memory will be present over here. Which one is this block? Which one is this block? Which one is this and which one is this? How to identify these blocks uniquely? For each block, I'll have to maintain tag. Separate tag. So wherever you organize the cache in whatever manner, for each block, you'll have to maintain tag and extra bits. So formula remains same, this one only. Number of blocks in cache multiply by tag plus extra bits. Okay. Now let's calculate tag and number of blocks in cache. How do you do that? It is a set associative mapping. Okay, we know that in the set associative mapping, main memory address we divide into 3 parts: tag, set and byte. 256 kilobyte 4-way set associative cache. These two fields, log of 256k minus log of k, which is log of 4. 256k, 256 to power 8, k to power 10, 18 total. Log of 2 power 18, 18 minus 2, 16. Processor sends 32-bit addresses. So what is the tag size? 32 minus 16, 16 bits. You got the tag? Yes. Extra bits. Each cache tag directory entry contains, in addition to address tag, 2 valid bit, 1 modified bit, 1 replacement bit. Number of blocks I don't know right now, but tag is 16 plus 2 valid bit, 1 modified bit, 1 replacement bit. These many bits. Let's calculate number of blocks in cache. Number of blocks in cache. Cache size divided by block size. Block size 32 byte block. Byte to byte cancel. 2 power 18 is 256k. 32 is 2 power 5. Answer is 2 power 13. So number of blocks in cache 2 power 13. Okay. How much I'll get answer? 2 power 13 into 16 plus 440. Nana, 20 bits. Do I get any answer of similar kind? No. They are having answer in kilobits. K. 2 power 10 separately. If I'll take 2 power 10 separately from here, power 10 gone, 2 power 3 remaining, which is 8. 8 into 20, 160. 160 kilobit, A option correct. So many members are doing this. Answer getting 40 kilobyte. Why? For each set they are getting the calculation. Number of sets will be 2 power 11. 2 power 11 into 20. Answer is 40 kilobits. So many members do that mistake. But while teaching also, while solving these questions, I have given you correct information that, my dear friend, whether it is whatever type of mapping, the tag directory size formula remains same. Give me a thumbs up if you guys are till now. Okay, then we'll go ahead with the next question. Theory based PYQ में मुश्किल हो रहा है. मुश्किल इसलिए होता है क्योंकि तुमको समझ नहीं आता. You can't understand what is written, and for that you need a lot of understanding of the concept. Concept grip is needed, and that takes a lot of time, lot of revision, multiple variations of or multiple iterations of revision needed. Another question, which is dividing the main memory address into 3 parts so that you can get tag. Okay, starting from 0 again. Very easy question it is. 1.5 minute gone. Anybody here is from Kurnool, Andhra Pradesh? This type of question have been asked not so frequently, but nowadays they are starting asking such questions. I'll give you 3 minutes. Three and half minutes gone. People are getting now answer A, B, D, 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 D. Okay. Question is misprinted. Okay, let's see. Machine with a byte addressable memory of 220 byte. Aha, it is 2 power 20 byte. Really sorry for that. Yes, and having 2 power 12 cache lines. Yes, this should be there. It is in the power, not in the normal thing. Now you can get correct answer, I guess. Hanji. Okay, main memory size 2 power 20 byte, block size 16 byte, direct mapped cache having 2 power 12 lines. Lines means block. Now I guess it is better to understand. Let the addresses of 2 consecutive bytes in main memory in the hexadecimal these and these. What is the tag and cache line address for main memory address E201F? See, the thing is, if this is given in hexadecimal, I'll have to make hexadecimal to binary, divide the binary into 3 parts and get the tag, byte and everything separate. First of all, let's draw the main memory address format. Okay, my bad, really bad. Main memory is 2 power 20 byte, hence main memory address should be of 20 bits. That is why in hexadecimal 5 digit, hexadecimal 5 digit means 5 into 4, 20 bits of binary I should get in address. Okay, now, this is the tag, this is block and byte offset. These 3 fields we divide the main memory address in the direct mapped cache. Direct mapped cache having 2 power 12 cache lines. Directly given number of lines or number of blocks are 2 power 12. So 12 bits gone for block number. Block size 16 byte, 2 power 4. So 4 bits gone for byte offset. 20 minus 16, 4 bits for tag. Okay, now this question is so easy. See what they have given: tag, block and byte offset all in the term of 4 multiplication. In the form of multiplication of 4, multiply of 4, 4 into 3 and 4. In the multiple of 4 means it is very easy. Directly from hexadecimal you can get the answer. You don't have to convert into binary. Why? See, hexadecimal 1 digit 4 bit exactly. This is my tag. 12 bit of binary means hexadecimal exactly, perfectly 12 bits means 3 digit. This is my block number and this is the offset. So this address E is tag in hexadecimal. 201 is the block number and F is the byte offset. Directly you can do it. But the thing is, here it is true. Why? Just because tag is exactly 4 bits. 4 bits means one hexadecimal digit exactly is same to same. 12 bits block. It is multiple of 4. That's why 3 next digits of hexadecimal as it is for block number. Just because each field is having multiple of 4, that's why directly I could do from here. But I'll give you another example. Okay, before that, let me put the answer. A option is correct. E is the tag in hexadecimal, in hex, and 201 is the block number or cache line number. But in the same question, let's say, if I am saying that these 20 bits are having like this, tag is having 6 bits, block is having 9 bits, and remaining byte offset 5 bits. If this is the case, example, I'm taking an example so that you can have the learning. Now you tell me hexadecimal address 2E201F in hexadecimal. You get the tag, block and byte number. Now you will have to convert this into binary. Why, sir? Previously you didn't do, now why you are asking? Just because previously, even if you convert E into binary, exactly E you get in hexadecimal, just because each field was in multiple of 4. Now I don't have every field in multiple of 4. So first 6 bits. 6 bits means 2 bits of this next digit also I'll have to take. Need to convert into binary this time. Do it now. Need to convert? Yes, do it now. Okay. E. What is E in the binary? 1110. 2. 4-bit binary. Every digit they converted into 4-bit binary. This 0 is hexadecimal 0. 4-bit binary. 1. F. Now convert this into this and 6-bit. This is the tag. 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is block number or line number. And this is the byte offset. Now, if they ask this number to convert back into hexadecimal or decimal, whatever, you should do that. If they ask this to be converted again in hexadecimal, what should I do? Starting from right, 8, 3. Starting from right, 0, 0 and 1. And this one, F and 1. Starting from the right, I'll have to convert this into hexadecimal. Okay, are you guys done with this one? Should we move to the next one? Okay, another question. Here it is. It's very easy again. See, this is what I have just explained you, and this is what they have asked back in 2008. Got it? Reset and go. This time at least you will be able to get the correct answer. And similar kind of questions you can expect now. Yes, we can have such kind of questions in GATE examination nowadays. Now at least you can get this answer correct, just because just now I have explained how to do that. Consider a computer with a four-way set associative mapped cache of following characteristic: 1 megabyte of main memory. People are getting answer A. Okay, now time is up for you guys. Four-way set associative cache. What I'll have to do? Divide the main memory address into three parts: tag, set offset, and byte offset. Main memory size 1 megabyte. 1 megabyte is 2 power 20 byte. So main memory address 20 bits complete. Block size of 128 words. One word is 1 byte, means 128 byte. So 7 bits for byte offset. Cache size 8 kilobyte. We know these two fields, log of cache size 8k minus log of associativity 4. 8k 13 minus 2 11. If these two fields are 11, set offset 4, 7 is byte offset, total 11, remaining 9 bits for tag. Now, if memory location this 0C795H, H is hexadecimal representation, then what should be the tag? What I'll have to do? I just don't want set offset and byte offset from this address. I just need leftmost 9 bit of this tag. 0 I'll convert into binary. 0, 4-bit binary. C, 11004 bit binary, and 7. From 7, 7 is 0111 in the binary of 4 digit. But I don't need these 3 bits. This is my tag. First 9 bits of the hexadecimal address. 4 times 0, 11, 3 times 0. Option A is correct. Very simple to do that. Very, very simple. Sir, if word size is not 1 byte but it is 2 byte, if word size will be 2 byte, block size I'll have to calculate in word. If main memory is also word addressable, if main memory is word addressable, I'll have to consider that particular fact. If main memory is not word addressable, but word size is 2 byte, block size is 128 word, then the block size will become 128 into 2 byte. Answer is 256 byte. So here you will have 8 bits, remaining 3 bits for set offset. That's the only change. मैंने h को 17 समझ के सॉल्व कर दिया। 17 कहां से आया बाबू? h 17 कैसे आ सकता है? हाउ इज इट पॉसिबल? h इज हेक्साडेसिमल। इन हेक्साडेसिमल there is no any digit beyond 0 1 2 3 4 5 up to 9 and then a b c d e f g, sorry, a b c d e f, that's it. There is no any g, there is no any h. Sir, the address has value of 6 hexa digit. By 6 it is 5 na. We have 5 only, 0c795, these are the only 5 digit. Why we don't have 6? Kahan hai 6? Where is 6? Rashmi ji, where is 6? They are people, IITians, professor. I took H as a letter. That is what the learning. I see, that's why I always tell students, please learn complete lecture series. I taught everything. When you represent any hexadecimal number in the number system, you represent it like this way in number system. Similarly, when a microprocessor representation comes, it comes with this. Ending with H is a microprocessor representation of hexadecimal. In microprocessor studies, you do this. A computer scientist, a programmer will do this. 0x is the prefix which says it is hexadecimal number. These are the representation of hexadecimal. And these are the basic things a computer scientist should know without even coaching classes. लड़का हूं, दादी के अकाउंट से आया हूं। ओहो, रियल आईडी से आओ बाबू। This question also same to same. You will have to get the set offset from all 4 addresses and we'll have to see what addresses are having set offset same and different. Similar kind of question, not the different one. Getting the answer or not? Okay, take your time, take your time. Getting any answer? B, B, B. Answer is B. Answer is B. Okay. Stop, 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 stop. Question is exactly same. But the thing is, previously they were asking about the tag. This time they are asking that these addresses are mapping to which cache set. So you'll have to get the set number out of these addresses, and that's enough. Okay, now see, a computer system with word length 32 bits, 16 megabyte, byte addressable memory. If byte addressable memory, I'll have to get everything in bytes. Main memory 16 mega, 2 power 4, 2 power 20, 2 power 24 bytes. Mean main memory address should be 24 bits total. Four-way set associative 64 kilobyte main memory. Sorry, cache. 64 kilobyte 4-way set associative cache, tag, set and byte. Look at this. Block size 256 byte. 8 bits gone here. These two field, log of cache size minus log of associativity. Log of 64k, 16 minus 2 power 16 minus log of associativity 4. 16 minus 2 is 14. 8 gone, 6 bit for set offset, 10 bits for tag. What exactly question is, if these 4 hexadecimal addresses, just now I explained 0x, if you do computer programming and when you print the addresses in hexadecimal, you get such kind of notation 0x. 0x is the prefix of hexadecimal. So hexadecimal, look at this, 6 digit. 6 into 4, 24 bit main memory address. Very simple, right? So 6 digit hexadecimal addresses are mapping to which cache set. I want to know each address ka only set number, these middle 6 bits. I just don't want tag, I just don't want byte offset. So what I will do, I'll go with the right side. Byte offset having exactly 8 bits. 8 bits means 2 hexadecimal digit. So these 2 hexadecimal digit gone for byte offset. From here I'll have to take middle 6 bits, rightmost 6 bits. Rightmost 6 bits 8, and from C I'll take 2 bits. So C is 1100. So I'll take only 2 bits 00 and 8. This is my set number for A1. A2 same. These 2 digits gone for byte offset. 8 1000, 6 0110. I'll have to remove leftmost 2 bits. These are my 6 bits for the set offset for this address. A2. A3 rightmost 2 digits gone for byte offset. 8 4 bits, 2 bits from 2. 0010 is binary of 2. Only rightmost 2 bit to make only 6 bit of set number. Pipeline question भी करवाएंगे बेटा. Yes. Hexadecimal, this digit gone. 8 1000, 4 0100. Look at this. This is a 00 1000, 10 1000, 10 1000, 00 1000. A1 and A4 are mapping to same set. 2 and 3 are mapping to same set. Set number are same. A1 and A4 are mapped to different cache set. Na, same to same, it is wrong answer. A2 and A3 are mapped to same. Yes, 2 and 3 same. 3 and 4 are mapped to same. 3 and 4 mapping to same. No, wrong. A1 and A3 are mapped to same. No, 1 and 3 are not mapped to same. Look at this, 1 and 3 different. Directly by just checking out the set number, you can easily get the correct option as B. Very simple. नेक्स्ट क्वेश्चन. सर बहुत ज्यादा टेंशन हो रही है, कल नेट जेआरएफ का पेपर भी है, कोई छोटी सी गाइडेंस. पेपर के बारे में सोचो मत, पढ़ाई मत करो, जस्ट बी रिलैक्स्ड. Easy question, should have been done till now. Consider a small two-way set associative cache. Two-way set associative cache consisting just 4 blocks. If 4 blocks in two-way set associative cache, number of sets will be how many? Number of blocks divided by associativity, 2 set. 2 sets, set number 0 and 1. That's it. You can think of like this way. Imagine set number 0, set number 1, each set having 2 blocks organized under it. For choosing the block to be replaced, LRU policy is used. Number of cache misses for following this is, of course, I'll have to imagine that cache memory is initially empty. If numbers are given in decimal, of course, which should have been written, nowadays they will write. This is very old question. They used to not write it. Now they'll write. These numbers are in decimal. If main memory blocks are given in decimal, how to get the set number? Main memory block number modulus by number of sets in cache. How many sets? 2. 0. 8 at 0 should present. It is not miss. I will bring 8 at 0. Next is 12. 12 modulus 2, again 0. Should come at 0. It's a miss just because 12 is not present. I'll bring it in the cache. Then 0. Of course, 0 modulus 2 is 0. It's a fault or it's a miss. Not present in cache, I'll bring. If I'll bring at 0, I will have to replace one of the blocks. Which block I'll have to replace? Either 8 or 12. LRU policy, which one should I replace? 12, recently used. 8 should be replaced. Next, 12. It's a hit. It is present in cache. 8, it's a miss. If 8 is the miss, I'll have to bring it again in the cache. Where should I bring? On set number 0. But on which place? Block number 12 should be replaced or 0? Recently used 12, keep it. Least recently 0, replace it. How many miss? 4. Can you tell me what type of miss these are? The very first miss, 8, 12 and 0, these 3 will be considered as cold or compulsory miss. Agreed or not? These 3 are cold miss. First 3. Why? Just because very first access. First access of block 8, then 12, then 0. All 3 are cold miss. The last one, block 8, is which type of miss? Last one is which type of miss? See, this block 8 got again miss. Is it the very first access? No. It is the repeated access, but still it is having a miss. Why? You replaced it. So it is not cold miss? Yes. I'll have to check if cache memory is completely full. No, cache memory is not full. If cache memory will be full, these blocks are also completely full, then I'll say capacity miss. If cache memory is not full but current set is full, it will be called as conflict miss. Definition you need to know. If we will be having fully associative na, then this block number 8 will not have another miss. You can see 8, 0 and 12 together, all three you can keep in single set. If you will have fully associative cache, single set all blocks 8, 0 and 12 all you can keep together. No again conflict miss you will be having block 8 के लिए. Okay, access time question. 1 minute. And very simple, yeah. For a certain processor, a read request takes 50 nanosecond for a misfire for on cache hit. Suppose while running a program, it was observed that 80% of processors read requests result in cache hit. Directly given for a miss 50 nanosecond, hit 5 nanosecond, you will have to use the general formula when 80% hit 5 nanosecond, when 20% miss 50 nanosecond, and answer is 14 nanosecond. This was the very first question in 2015 GATE examination. Very first question. Set number 2 it was. Now you realize how did I get those ranks 440 and 119 and so on later on when I was not even preparing for GATE. I prepared for GATE. I got in final year, yes, just because I was fully committed to GATE. But after that in 2018, I got 440. This, why, how? Just because of such kind of question. So many easy questions are coming from your courses. Next question. Let's begin. Won't take much time. Minutes gone. I am waiting for you guys. Not so many answers. How is it possible? Okay. See, cache memory has a hit rate of zero point 0.8, has an access latency of 10 nanosecond and miss penalty 100 nanosecond. And optimization is done on this cache to reduce the miss rate. However, the optimization results in an increase of cache access latency to 15 nanosecond, whereas the miss penalty is not affected, means remain 100 nanosecond. The minimum hit rate rounded off to 2 decimal place needed after the optimization such that it should not increase the average memory access time. So whatever previous average memory access time was there, same to same average memory access time I want now. In this question, the biggest question you can have is, sir, should I use the hierarchical access or simultaneous access? Whatever you use, you will get correct answer. If it is a gate question, you can use anything. But if it is a PSU question, I will go with the a simultaneous access. Why? Just because there is no any word in the question mention label or hierarchy. PSU, go with the simultaneous access as the default one. So I'll have to calculate T average. Let me calculate T average by simultaneous access. 0.8 into 10 plus 0.2 into miss penalty 100 nanosecond, which is 8 plus 20, 28 nanosecond. Now I'll have to keep T average as it is. Now hit rate I don't know. Access latency of cache has become 15. Miss rate into cache miss penalty this much. H, how much it is? 28 is equal to 15H plus 100 minus 100H. 185, it becomes 72 divided by 85. 0.847 decimal place. Still two decimal place. 0.847 means 85. Answer is 0.85. Even if you go with the hierarchical access, you will get same answer. सर एडवर्टीजमेंट आया, बढ़िया, देख लो, खुश हो जाओ. सर यहां तो क्वेश्चन बन रहे हैं, टेस्ट देते वक्त ब्रेन फोग हो जाता है. दैट इज व्हाट वी विल हैव टू इंप्रूव. By writing and attempting so many tests, we will have to improve. Let's go with this question now. Next. कैश एक्सेस इंक्रीज टू 15 नैनोसेकेंड, इंक्रीज्ड बाय 15 नहीं है, इट इज इंक्रीज्ड टू. द डिफरेंस इज इंक्रीज्ड टू इज मीन्स 15 नैनोसेकेंड पे इंक्रीज कर दिया गया, इंक्रीज्ड बाय नहीं है. इंक्रीज्ड बाय मीन्स इंक्रीज्ड बाय 15, 10 plus 15, 25. It is a PYQ. It is very easy. See, the thing is, in this question, you will have to calculate the block transfer time when there is a miss. During a cache miss, you will have to transfer the block from main memory to cache. That you will have to calculate. Solve karo, answer lao. Let's get the answer quickly. This much time we should not take it here, Ray. 1 megabyte direct mapped cache, block size 256 byte. Cache has an access time of 3 nanosecond, hit rate 94%. During a cache miss, it takes 20 nanoseconds to bring the first word, not the byte, first word of the block from main memory, while each subsequent word takes 5 nanoseconds. Each later on every word will take 5. First word takes 20 nanosecond. Now block, if I'll have to bring, block size is 256 byte. They have given block size in bytes, but they are giving transfer time in terms of word. I'll have to convert block size in the word so that I can calculate. One word size 64 bit, 8 bytes. How many words we can have in the block of 256 byte? Each word 8 bytes. 56 byte. It is simple aptitude. 256 byte divided by 8 byte. How many words? 32 words. Right. Next. Now, let's calculate block transfer time. Block transfer time is first word of the block takes 20 nanosecond. Among 32, remaining all 31 will take only 5 nanoseconds. 175 nanosecond is the block transfer time when there is a miss. Now again, it's a gate question. You can take hierarchical or simultaneous, whatever your answer is accepted. If I go with simultaneous, when there is a hit, then only 3. When there is a miss, 6% time, then 175. You get answer 13.32 something. Up to 1 decimal place they are asking. 13.3 nanosecond is the correct answer. If you go with hierarchical axis, you will get this 13.5. That was also accepted. Answer given was 13.3 to 13.5. One of the biggest mistake people do in such kind of questions is after decimal up to how many places they are asking the answer rounded off. If they are asking rounded off to 1 decimal place, you will have to answer 13.3 only. During crash course, all other courses, I always talk about this question just because one of my student who ended up at the end in IIT Bombay, but he made this mistake. Up to 1 decimal place, they asked the answer and he has written 13.3 to up to 2 decimal places. His answer got rejected automatically, but the correct answer is still rejected. In this question, so many students got 0.847. People don't know what is the rounding off, and you are expecting that you can become IITian. Students are saying, sir, I got 847, so up to 2 decimal place I have made 84. This is rounding off. Seriously, you don't know rounding off. If you don't know rounding off, learn it. It's a mathematical concept already available on YouTube. If the next third digit is more than 5 or equal to 5, just plus 1 in the second digit. This. If this is more than 5 or equal to 5, just make it 1 increase. That is the basic rule of the rounding off. You should know it. But people are not following it. Why? I don't know why. Simple, rounded off to decimal place. Clear cut written. 0.84 people are writing, students are writing and then saying, sir, will I get correct answer? Will I get marks in this question? No, they will reject, of course. Why they'll give correct answer? You made a mistake and you are again asking me this question. How is it possible, Ra? Please, you guys are serious enough now. You guys are intelligent enough now. So such kind of mistake don't do. One more thing. I have made a video, specific video how to avoid the silly mistakes during the test. In that also I have told the same thing. When you solve complete question numerical, when answer is done, you will have to review it. What you did, what you calculated, how many places, decimal places answer is asked. Did I get it correct or not? In what unit they are asking, percentage or just fraction? Did I get the answer in the same unit or not? They are asking whatever I have calculated or not. Review it. Most of your silly mistakes will be eliminated. They are asking true or false. Did I correct it true or false? All these things if you do, you'll have a correct answer. Okay, let's move to the pipelining. 1.5 minutes. Got the answer? Okay. Three-stage pipeline processor having delay 10 nanosecond, 20 and 14 nanosecond for 3 stages. Assume that there is no any other delay of processor does not suffer any pipeline hazard something. Also, one instruction is fetched every cycle. Total execution time for 100 instructions are how much? Total execution time is k plus n minus 1 into tp. K is number of segments 3, n number of instructions, TP is cycle time. How do you calculate TP? Maximum of segment delays. Segment delays 10, 20 and 14. Maximum of these 20. 102 into 20 is 204 and 0, 2040 nanosecond. In the nanosecond only asked, 2040 was the answer. This was last year's gate question. Very simple. इससे सिंपल और क्या चाहिए? What you will get apart from this now? It is very simple question and similar question have been asked previously also. Again, same formula, 4-stage pipeline has delays 150, 120, 160, 140 nanosecond. Registered delay is also now. So if you want to calculate TP, maximum of segment delay plus registered delay 165 nanosecond you will get. Pipeline processing time for 1000 data item is 4K plus 1000 minus 1 into 165. 1003 into 165. 165. I think there is a printing mistake here, typing mistake here. It should be 165.5, है ना? You guys are not realizing, but I am getting it. So 165, 495 nanosecond. They are asking answers in microsecond. Microsecond, I'll have to convert this in microsecond, means divide by 1000. This much. Approximately C option is correct. 165.5. Another question of similar kind. Here the speed up is asked. This is one of the really easiest question which has been asked in GATE examination. Very, very easy. Answer what it says. Instruction pipeline has 4 stages, S1, S2, S3, S4. Each combined with combinational circuits. The pipeline registers are required between each stage and at the end of the last stage also. Delay of the stages are given like this: S1 5, S2 6, S3 11, S4 8. Similarly, register delay also given 1 1 1 1 each, 1 1 1 and 1. What is the approximate speed up of the pipeline in steady state under ideal conditions? Under ideal conditions, speed up is Tn divided by Tp when there is no any stall. No stall is given in the question. Tn divided by Tp is the speed up. Now, how do you get Tn? Summation of all the segment delay without any register. 5, 6, 11 and 8. 5 plus 6, 9, 11, 11, 22, 8, 30 nanosecond. How do you get TP? Maximum of the segment delays 5, 6, 11 and 8 plus register delay 1, which is 12 nanosecond. Let's put up these values. That's it. 30 divided by 12. And answer is 2.5. Nowadays, what these guys are doing? They are adding the additional stalls. If they will add additional stalls in the pipeline, what happens? Here you will have to multiply CP of the pipeline, CPI, cycle per instruction. That's the only difference. Nowadays, they are adding that extra. Apart from that, Similar kind of questions they are asking so many times. Sir, can we bypass any stage in non-pipeline? Why? Why to bypass the stage? Okay. Oh, it's not in nanosecond. It's a speed up. Yes. It is the speed up. Answer will be just 2.5. Okay. Another question. Here it is. Very, very easy and interesting question. Nowadays, these guys are asking similar kind of questions. Hey, okay. Stop. What it says? Let's see. Non-pipelined processor with a clock rate of 2.5 gigahertz and average cycle per instruction of 4. Same processor upgraded to pipelined processor with 5 stages, but due to internal delay, the clock speed is reduced to 2 gigahertz. Assume that no stall is there in the pipeline. Speed up is what? Now, again, in this question also, speed up is asked, but there is no any value of n given. Previous question, they have asked speed up in the ideal condition. We have written this formula. We will have to use same formula again. Why, sir? Just because no value of number of instructions given. So if number of operations, number of instructions not given, speed up we will use same formula Tn divided by Tp. Now previously Tn and Tp we calculated by the stage delay. Now we will have to calculate the same thing with the help of the clock rate. Okay. Tn is one complete operation time in the non-pipeline, which is number of cycles to execute one instruction divided by, multiply by cycle time. Cycle time I'll have to calculate from here. How much it is? 1.6 nanosecond. 4 cycle per instruction to execute one instruction, 4 cycle needed, and each cycle time is this much. This is Tn time. Tp is one cycle time in the pipeline. One cycle time, which is 1 divided by clock rate 2 gigahertz. Tn is not one cycle time. Tn is one complete operation or one instruction execution time in non-pipeline. Tp is one cycle time. That's it. Which is 0.5 nanosecond. Let's put up the value. 1.6 nanosecond divided by 0.5. Answer is 3.2. That is the correct answer. Now this type of question has been asked again in 2020, but that time they added the stalls. additional stalls. So when they added the stalls, we will have to do what? You will have to calculate CPI and multiply it with TP here at the downside. That's the only difference in this question and those questions. Multiply TP. Yes, exactly. And this was the question. Three minutes. Will you take 3 minutes to solve this question? Only different thing in this question is you'll have to calculate the CPI and use the formula Tn divided by CPI of the pipeline into TP. How to calculate CPI, that we have learned. Few more seconds I'll give you guys to solve this question. See, you don't get pipelines speed up lesser than 1. If you are getting pipeline speed up lesser than 1 means pipeline is even worse than the non-pipeline system, which is certainly not good idea. You should not get answer lesser than lesser than 1. Okay, fine. 4 minutes are, I guess, enough to solve this question. Non-pipeline processor operating at 2.5 gigahertz and 5 clock cycle to complete an instruction. Immediately we can calculate Tn 5 cycle, each cycle time 1 by 2.5 gigahertz, which is 2 nanosecond. You are going to make a 5-stage pipeline k equals to 5 out of this processor. Overhead associated with the pipeline, forcing you to operate a pipeline processor at 2 gigahertz. So pipeline cycle time TP you calculate by 1 divided by 2 gigahertz, which is 0.5 nanosecond. In a given program, assume that this particular thing, now I'll have to go with another page. So what it says, in the program 30% are memory instructions. 30% are memory instructions among all the instructions. Next, 60% are ALU instructions. 60% are ALU instruction, remaining 10% now. And rest are branch instructions. So 10% are branch instruction. Next, 5% of the memory instructions, not all, only of memory instructions. Among all memory instructions, 5% of memory instructions cause stall of 50 cycles each due to cache miss. So among 30% overall instructions which are memory access, total instructions 30% are memory. Among those, 5% are only causing 50 stalls. Next, 50% of the branch instructions cause a stall of 2 cycles each. Branch instruction, all instructions, branch instructions, 50% causing 2 stalls each. Assume there is no any stall associated with execution of ALU instructions. For this program, speedup achieved by the pipelined processor over non-pipelined processor up to 2 decimal places. Watch. Okay, let's calculate the CPI. CPI of the pipeline is 1 plus stall frequency 30%, 5%. 30%, 5% will cause 50 stalls plus 10%, 50% will cause 2 cycles each. How much it is? Point 0.5 into 2 into 0.1 plus 0.05 into 0.3 into 50 plus 1.85. This was the only thing different than the previous question. Now let's go solve the question based on what we discussed. Tn 2 nanosecond divided by CPI into TP. TP is 0.5 nanosecond. When you solve this, what I do is 2 divided by 0.5 is 4, divided by 1.85, answer is 2.1621. Look at this, up to decimal place they are asking 2.16 and 2. I can just remove this to rounding off. 2.16 is the answer. I have not made it to 2.17 just because if third digit will be more than 5 or equal to 5, then I can make it, otherwise not. Another question. This was another brilliant question asked, and it has a really one small trick statement which so many students have missed. Another brilliant question this. Again, look at this, speed up is asked. If speed up is asked, you will have to go with the assumption that you will definitely have more than one value, greater than one value. Okay, 3 minutes gone. I do have two, three answers. Let's see. Wait. See, X1 is operating at 2 gigahertz, has a standard 5-stage instruction pipeline, base CPI of 1 without any hazard. We know that base CPI is 1 in the pipeline when no hazard is there, and operating at 2 gigahertz. For a given program P, which has 30% branch instructions, control hazard incurred 2 stall cycles every branch. Okay, so this is my old pipeline where 30% of branch instructions each causing 2 cycles. So CPI is 1 plus 0.3 into 2, which is 1.6. Further, a new version of processor X2 operating at same clock frequency. If frequency is same, average instruction execution time, CPI into cycle time. I will cancel out that cycle time later on anyway. Further, I'll explain how it works. Frequency is same. Additional branch predictor unit that completely eliminates stall for correctly predicted branches. If accuracy or accurately you predict the branch correctly, then no any stall. But if wrongly predicted branch is there, then stall will be needed. How much? There is neither any savings nor any additional stalls for wrong prediction. If prediction is wrong, no any additional stall is needed, but whatever stall needed for branch, that is needed, and that is two stalls. Two stalls needed for wrongly predicted branch. You cannot save the stalls for wrong prediction, but you will not add extra stalls also. Only 2 stalls needed for wrong prediction also. Great. There is no any structural hazard, data hazard, only branch hazard are there in X1 and S2. BPU prediction accuracy is 80%, which means only 20% of the branch instruction are predicted wrongly. So in the new CPU, the CPI will become 30% branch instruction. Among them, only 20% are getting the stall. Why? 80% are accurately predicted and branch prediction unit is completely eliminating the stall. Only 20% of the branch instruction will have the stall of 2. How much? 0.6 ka 0.2. 1.2. 1.12. Now, simple. The speed up is 1.6 divided by 1.12. How much you are getting? 1.4 1.28 something, up to how many places? 2 decimal places. 1.43. You'll have to get the answer 1.43. 4 to 8 it is, so 4.3 is the correct answer. Now see, if clock rate of the processors will be different, what I'll have to do is I'll have to calculate average instruction execution time here, which will be 1.6 into cycle time, 1 by 2 gigahertz. And here also average instruction execution time I'll have to calculate, cycle time. And then I'll have to divide this slower time divided by faster time if clock rate will be different. But just because clock rate is same, here CPI into cycle time, here CPI into cycle time to cycle time, both cancelled just because same values. If it is same value, no issue. If not same value, then gadbad baba, you will have to calculate what? The average instruction execution time. And then you'll have to divide average instruction execution time slower divided by faster. I hope you guys are understanding. I did not calculate it just because clock cycle is same, CPI are different, so directly clock cycle to clock cycle I cancelled out. When I was a kid, showing this was the sign of, making mockery of something like that. But nowadays it has changed. Showing this means, wow, nice man. Okay, thumbs up. Emoji, very famous nowadays. You are sending this emoji. Sometime, long ago when this emoji world was very new and my dad started working, on WhatsApp, I have sent him this. He called me immediately. What happened to you? Actually, he spoke in Hindi. क्या हुआ तेरे को? क्यों मजाक उड़ा रहा है मेरा? And I am like, oh, sorry, Dad. This is the okay sign. I'm not mocking you. Don't worry about it. Okay, another question. Here it is. These kind of questions have been asked 2010, 15, then before that also 2008, and after that 2018. Similar questions. And I have explained it very well how to solve such questions. Very simple. Got the answer, getting the answer. Array, I need more answers. Ravi Shinde, Raj, Vanshika, Rohit, Jitesh. Remaining other members. Jyotiraditya. सर आपसे टेलीग्राम पे क्वेश्चन पूछा था 2021 के पाइपलाइन का ऑपरेंट फॉरवर्डिंग बेस्ड पे, आपने यहां कवर करेंगे? नहीं जी। Question I did not bring, but you can get it online. I have solved it live. Told you, right? Okay, 3 minutes gone. Should not take more than that much time. 4 instructions. Above instruction R0 to R8 are general purpose registers. Instruction shown. First register stores the result of operation performed on second and third. So these are the destination first. Sequence of instruction to be executed in pipeline. 4-stage pipeline, k equals to 4. And given that IF, OF and WB stages take 1 clock cycle each. IF, OF, EX or PO? PO it is. PO and WB. IF take 1, OF take 1, WB take 1. PO. The PO stage take 1 cycle for addition and subtraction, 3 for multiplication. Addition 1 cycle, subtraction 1 cycle, multiplication 3 cycle and division 5 cycle. Great. If some instructions are taking extra, should take 1. This is taking 2 instruction or 2 cycle extra. This is taking 4 cycle extra. Total 6 cycle multiplication and division. 1 multiplication, 1 division, 1 addition, 1 subtraction. So 1 multiplication will take 2 extra, 1 division will take 4 extra, 6 extra cycles are needed apart from the regular cycles, which is k plus n minus 1. So k 4 stages plus n 4 number of instruction minus 1, 7 cycles needed without any hazard, but due to structural hazard 6 stalls are needed. Answer is 13. There is no any data hazard I'm considering, just because given that we have operand forwarding, and if operand forwarding is used, all are the ALU instruction. Operand forwarding will take care of the data hazard. There is no any branch instruction, so branch hazard is not there. Data hazard solved by operand forwarding. Branch hazard is not there, only structural hazard, 6 stalls. Answer is 13. Rohit, you are talking about that add multiplication question. You can find out it in the playlist. PYQ playlist is there. In that you can find it out. Sir, won't data dependency cause one stall cycle? No, of course not. Just because if operand forwarding is used, there is no any stall needed here. Rohit, search COA PYQ playlist Vishwadeep. Latest PYQ playlist, you will, if you will check, maybe 22, 23, something like that, you will be getting that playlist. In that you'll be getting that answer. Again, similar kind of question, exactly similar kind of question, just some numbers are different. Stage pipeline, IF, ID, OF, PO and WO. IF, ID, OF, PO and WO. The IF, ID, OF and WO stages take 1 cycle each for all type of instructions. The PO stage take 1 for addition and subtraction, 1 for addition, 1 for subtraction. But multiplication 3 cycles, 6 for division. Multiplication 3 cycle, division 6 cycle. Operand forwarding is used in the pipeline. How many number of cycles are needed? Each multiplication will cost 2 stalls. Each division will cost 5 stalls, 7 stalls, just because you have one instruction of each type. Operand forwarding is used given in the question. All the type of instructions are ALU. Operand forwarding will take care of all the data dependencies. No any branch instruction, no data, no branch difficulty or problem. Here only what? Structural hazard. So without any hazard, number of cycles k plus number of instruction n minus 1, 8 cycles. Stalls we have calculated how many? 2 plus 5, 1 multiplication 2 division 5, total 7 stalls. Answer is 15 cycles. See, this was the reason I got the rank 2010. Such kind of questions were there. Similar kind of question, another. Similar kind of question, another. So many similar kind of questions these guys are asking. Oh. 3 minutes, maximum 2.5 minutes to 3 minutes. Very easy question. Similar kind of question it is. Risk pipeline has following stages: IF, ID, OF, PO and WB. IF, ID, OF, PO and WB. IF, ID, OF and WB taking 1 cycle each. PO takes how much? A sequence of 100 instructions is there. In those 100 instructions, 40 instructions are taking 3 cycles. 35 instructions taking 2 cycles. 35 instruction taking 2 cycles. And 25 instruction take 1 cycle. Whatever instructions are taking one cycle, no stall in that. But whichever are taking more than 1, here more than 1. More than 1 how much? 1 extra, 35. Each will take 1 extra, 35 extra. 40 instructions, each will take 3 extra. Sorry, 2 extra. 3 means 2 extra. 80. 80 plus 35. 115 stall cycles are needed. Okay, without stall, how many cycles? K, 5 stages plus 100 instruction minus 104. Stalls we calculated how many? 115. Answer is 219. GATE 2018 question. 2 mark. And that much only you had to write. Hardly 2 minutes. If you know how to approach. That's why I always tell you, similar kind of question which have been asked multiple times in GATE, you need to know the approach very quickly. You can jump into the conclusion that this is the way I am going to solve and this is the answer of my final question. In the GATE examination, it should happen. so that you can spend extra time for the another question. Okay, we are jumping next on to the floating point representation. A few questions from there too. Let's go. This is another very easy question. No, should not take more than 2.5 minutes. Got the answer. So many people have got the answer. कैसे करेंगे? Let's find out how to do that. In floating point representation, we represent a number in 32 bits when single precision is there. Those 32 bits sign 1 bit, exponent which is biased exponent 8 bit, and mentees are 23 bits. Whatever number is given negative, if it is negative number, so sign should be 1. Sign bit 1 bit, I should have 1. Now let's take the value separately. 14.25. I'll have to first convert that 14.25 of decimal into binary. 14 is 1110, 0.25 is 01. I'll have to make it in the implicit normalization. Why? Just because floating point representation represents the number in implicit normalization if it can be done. Implicit normalization means convert the number into 1 point something form. 1 point something, this point I'll have to shift 3 position left. Hence, I'll have to multiply it by 2 power 3. So if you multiply 2 power 3, 3 position, point will shift in the right. From here, Mentisa I'll get. What is the Mentisa? After the point 11001 and original exponent is 3. I don't store original exponent. You remember that? I do not store original exponent as it is. I will store the biased exponent, which is small e plus bias. Bias is in the single precision. If it is not mentioned in the question, bias is 127. So capital E is this plus bias. 130 of decimal. 130 of decimal means 130 of decimal means what? 1, 2, 3, 4, 5, 6, 7, and 8 of binary. Let's put up this here. 1, 2, 3, 4, 5, 6, 7, 8. Mentisa, I'll have to make 23 bits. I do have only 1, 1, 0, 0, 1. Remaining 0 I'll have to add, but in the right side. Why in the right side? Just because Mentisa is the number after the point. This. If this is the Mentisa after the point, I'll have to add zeros in the right side. Now let's convert that into hexadecimal. 1110C, 0001 is 1, 0110 is 6, 0100 is 4, remaining all 0. C1640000, A option is correct, 32 bits. Are we gonna take a small break? No. Till 5 p.m. we will complete all the questions and done. No break today. Another question. Similar, just opposite. Previously, value was given. This representation was asked in the hexadecimal, binary, then hexadecimal. This time they are giving binary conversion. You will have to convert it into the decimal. This is so easy. I am not giving you the timer. Oh, I should give you the timer. Let's have it. This is easy now. Hey, 1.5 minutes is enough, I guess. See, exponent is not 0, not 1. All not all 0, no. All 1, no. Means it's an implicit normalized number. Sign is 1, means negative. Let's get the value directly. Put up the formula. 1 point Mentisa, negative ka 1 point Mentisa, Mentisa means fraction 1111 into 2 power capital E. This capital E in the decimal is 128 plus 1, 129. So capital E 129 minus bias 127. Why I subtracted? Previously I have added. When I store capital E here, it is the biased exponent. We add bias and store it. So when we want to get the original value, we subtract the bias and get the original value. 1.1111 into 2 power 2, which is point. I'll shift 2 position right side to make the value this. This is the binary number. Minus 111 is 7, 11 is 75. 7.75 in the minus is the correct answer. You get 2 marks up to decimal place if you put up this minus 7.75. Another question which was very easy for this kind of questions. Okay, without this only I'll give you. So easy question. This is so easy. I have discussed this multiple times in the classes. But the answer, see what it says, single precision floating point representation. Which one of the following choices is correct with respect to the smallest normalized positive number? Smallest normalized. For normalization, exponent should not be all 0. So minimum possible value is 1. So this option C and D are gone just because exponent cannot be all 0. Now, exponent minimum value is 1. What can be the mantissa? If exponent is not all 0, not all 1, mantissa can be anything and the number will become the normalized. So mantissa can be all 0, all 1, anything. Yes, minimum possible value, smallest value is all 0. So option B is correct. Exponent is 1 and mantissa all 0. That is the correct answer. This was GATE 2021. Good enough. Instruction chapter question. Two types of instruction supported. This is another simple question for you guys. When multiple type of questions or multiple type of instructions are supported, you will have to start with that instruction where we have minimum opcode bits. Minimum opcode bits. Okay, this, so many students are getting different answer. Let's see. 64 registers are there in a processor. So whenever I will require any register numbering based on 64 registers, 2 power 6, 6-bit register number I will use wherever in the instruction register number to be referred. 16-bit instruction format, two types of instruction, I type and R type. So two types of instructions are there. I type and R type. I'm writing it. This is I type. This is R type. Fine. Each I type instruction contains an opcode and a register name and 4-bit immediate value. So I type instruction contains an opcode, a register name or number and immediate value. Immediate value field is having how many bits? Just 4 bits. Register number 6 bit. Instruction length 16, so 6 bit remaining for opcode. Next, each R type instruction contains an opcode and 2 register names. Register number 1 and register number 2. Each register names are 6 bits. Instruction is 16 bit. Hence, opcode remains 4 bit. Cool enough. What is given? If there are 8 distinct I type in opcode, then maximum number of R type of opcodes possible. C, I don't care which type of instructions are already given. I'll have to start from that type instruction where we have minimum opcode bits here. Minimum opcode bits here, 4 bit. With the 4 bit, how many maximum opcode combinations we can have? 2 power 4, 16. How many are R-type used opcodes given in the question? Not given, sir. If nothing is given, something we take as X. This we are doing since our childhood of mathematics. If something is not given, we take it as X. So how many unused opcodes we will be having? 16 minus X. Using these unused opcode, we will have the I-type opcodes. This I-type opcode 6-bit, I'll have to divide into 2 parts. What are the 2 parts? Just previous level opcode bits 4 and remaining 2 bits among 6. Now, from these starting 4 bits, opcode which are unused from previous level are 16 minus X into 2 bits, all the combination 2 power 2. These are the maximum I type instruction I can have, which is equal to 8. Given in the question here, I type instruction 8. So whatever equation I got equal to 8, 2 power 2, 4 comes in division, becomes 2, 16 minus X is equal to 2, X value is 14. So we have maximum 14 I type instruction, sorry, R type instruction. That is the correct answer, GATE 2020. Okay, now we go for DMA. This type of question they have asked 2 times in the recent past, last 3 years. Actually, last 4 years, 2 times. Similar kind of question. 21 and then again they have asked the question in 2024. 3 minutes I'll give you. Do you know how to solve these questions? But the answer? Okay. See, in DMA, percentage of time CPU blocked. That particular formula is simple. Time to transfer the content to memory divided by time to prepare the data in the device into 100%. This is the formula. The question says that a DMA support is there in computer system. DMA module is transferring 8-bit character in one CPU cycle from device to memory through cycle stealing mode. One CPU cycle is actually TY time, and one cycle time you can get from here. So if one cycle time is 2 megahertz, clock rate is 2 megahertz, 1 divided by 2 megahertz, you can easily get zero point 0.5 nanosecond. Sorry, mega means microsecond. 0.5 microsecond is TY time. In that TY time, 0.5 microsecond, one cycle time of CPU. CPU is transferring the prepared data of 8-bit into the memory. 0.5% of processor cycles are used for DMA, means 0.5% time CPU is blocked due to DMA. 0.5% is equal to TY divided by TX into 100%. TY already calculated, which is 0.5. So TX is what? 0.5 to 0.5 cancel, 100 microsecond. 100 microsecond. Why? This zero point 0.5 is microsecond. 0.5 microsecond remains microsecond. 0.5 to 0.5 cancel. Percent to percent cancel. TX value is 100 microsecond. In 100 microsecond, device is preparing the data of 8 bits. In 100 microsecond, device is preparing that data of 8 bits inside the device, internal transfer speed of the device. So they are asking transfer rate of the device per second, how much? In 100 microsecond, 8 bits, then in 1 second, how much? That is only I'll have to calculate. So what I'll do here, I'll write down in 100 microsecond, bits transferred is equal to, or data transferred is equal to 8 bits. In 1 microsecond, data transferred is 8 bits divided by 100 microsecond. This is 8 per 100 microsecond. I'll have to calculate in the per second. So in 1 second, how much data is transferred? I'll have to convert micro into second. 100, 10 to the power minus 6 second. Minus 6 goes up, becomes plus 6, plus 6 to these 2 0 cancelled, 4 zeros are remaining. 80,000 bits per second is the answer, and that you will get correct answer. 2 marks if you will get the 80,000 is the correct answer. 80,000. So what is different in this question? Nothing. It's just that they have given this formula to be used from this TX time, preparation time, this transfer rate is asked. Usually whatever question we solve, transfer rate is given, through that we calculate the preparation time and then use this formula to get the percentage of time CPU blocked. They have given it in the reverse manner, and they enjoyed solving this question, or I should say they have seen that so many less percentage of the student could solve this question at that year. They have given another question of similar kind in 2024. रुक जाओ भाई, रुक जाओ. Now I think you should give correct answer for this question. I guess this one you will be able to make. But the answer, options, which option is correct? A option, 3 members getting correct answer. Remaining where? Remaining are where? 256 000 256 4 times 0. 3200 32 These two are only options remaining. See, okay, similar kind of question. A computer with 4 megahertz processor, if DMA controller can transfer 8 bytes in one cycle from device to main memory through cycle stealing mode. Same, TY time is one cycle time, which is 1 divided by 4 megahertz, 0.25 microsecond. Further, given that DMA controller is using 1% of the processor cycles, percentage of time CPU blocked is 1%, is equal to Ty divided by Tx into 100%. Percent to percent cancel, Tx is equal to 25 microsecond. In 25 microsecond, how many? 8 bytes data. 8 bytes data is transferred, but transfer rate they are asking in bit per second. Okay, so I'll have to write it like this way. In 25 microsecond, the device can transfer the data is equal to how much? 8 bytes, which is nothing but 64 bits. Yes, in bits. So in 1 second, how much data transferred? 64 bits divided by 25 microsecond. I convert micro into second. 64 into 10 power 6, 1000, separate 1000, separate 25, 40. 64 into 4, 256, 0 and 3 more zeros. 256, 4 times 0 bits per second is the correct answer. A option is correct. We do one more CPI speed up based question. You can just solve the PYQs remaining, so PYQs, and you can easily get the answer. One more PYQ is there, similar kind. You will have lot of question actually are there similar kind. If you will solve those questions, you will have the idea. If I will make it, you will not get the idea. You try your level best to solve it and understand by yourself. You will have more idea. It will be helpful for you. Okay, fine. So this was, I guess, it. This was the last question of the series. Great. I thought we will have 3 hours, approximately 3 hours we have taken. Now we will meet at 7 p.m. At 7 p.m. we will meet on Gate Wala channel CSECEE for more practice questions, and those questions are different. Those questions are different, means not from the GATE PYQ. I have curated some questions for just practice purpose so that you can have easy, medium, hard, every type of questions practiced, and you will have the idea how to solve new type of questions. Okay, सर सुपर 1500 के क्वेश्चन रिपीट होंगे क्या? थोड़े डिफरेंट, थोड़े नहीं. रिपीट तो नहीं होंगे. Similar kind of question you may find out, but these will be little different than the complete question. Can we ignore disk? See, the thing is, I don't know if the question will be asked from the disk or not. There are so many questions we have not discussed over here. There are so many topics which we have not discussed over here. There are so many concepts which we did not discuss over here. I could discuss only those concepts where the most number of questions have been asked and very frequently asked, so that we can at least utilize those topics. Okay. Do you know when the CN revision starts? Yes, 2 days. 7, 8, 6, 7, 8. 8. I guess computer network is from the 8th. Okay, so from 7 p.m. onwards, we'll be having some different kind of conceptual questions discussed. See you there at that time, 7 p.m. Okay, thank you. Bye bye, everybody.